Hello class, this is the third example on trigonometry with bearings. So let's get straight into it. So a plane flies from point A to point B on a bearing of 53 kilometers. I just realized there's no distance here. Okay, so let's just say the plane flies, I don't know, 25 kilometers from point A to point B on a bearing of 53 degrees true. So let's draw this first. Once again, since it's a bearing question, we have to draw a compass rose in the middle of our page here. So let's just draw, I don't know, here we go. There's our compass rose. Nice and simple. That there is north. Okay, so 53 degrees now, but if this is 90, this is 90 degrees if you're facing this way, it has to be in between here. So going clockwise 50 degrees, halfway is 45. Let's just make it slightly past halfway. It doesn't have to be perfectly accurate. Remember, this is just a diagram to represent what we are trying to calculate. So there is our drawing. And our angle is this one here. Always starting from north, going clockwise. This is 53 degrees. Okay. Sorry, and also it's 25 kilometers, so they flew in this direction for 25 kilometers. Let me make that a little bit larger there so you can see it. 25 kilometers. So now, how far east is B from A? So now in this one, we have to start labeling our points. So if it says a plane flies from point A, that means our starting point is here, which is from point A. So our point A is our starting, which means we ended point B. Okay, so now it's asking how far east is B from A. How far east is B from A? Which pretty much states that had we gone east, directly east from A, like so, until we are perpendicular with our point B, so this is what we're calculating now, here. How far east? So from A to going east, this is our missing value here. So now we need to work out the angles we're going to be working with. I'll give you a moment now to try and figure out one of the two angles to work with. Either we work with this angle or this angle. Give you a moment. Here we go. 3, 2, 1. Okay. Well, if this angle is 90 degrees, because remember, north and east are 90 degrees from each other. If that is 90 degrees, and this is 53, this angle plus 53 should add up to 90. So if we do 90 minus 53, well, this angle here has to be 37 degrees. The other angle, this one here, can be calculated by noticing that this angle, so this line and this line are parallel. And if we just turn it to the side here, you can sort of see that these two form a Z. And if you can remember from properties of geometry, they are alternate angles. So this one is also 53. And like in my previous video, you don't have to do both methods. You can figure out this angle and work with it, and then you can stop there. Or you can figure out this angle and work with this angle and the side and work with this. For this, I'm going to be showing both. Okay, so let's work with this angle first. From this angle, x is opposite, and 25 kilometers is the hypotenuse. So opposite hypotenuse, that is sine of 53 degrees, x over 25. So this is now going to be 25 sine 53 equals x. So x must be, we can just now pipe this in. You can see a right angled triangle here. So 25 sine 53. That will give us 19.965, which rounds up to 19.97 kilometers at 2 decimal places. Let's now work with the other angle. You don't have to do both, remember, but for these examples I'm showing both just to show you that had you found this angle and worked with these this information, you should come up to the same conclusion. So from this angle, x is adjacent, and 25 is the hypotenuse, which means adjacent hypotenuse is cos of 37 degrees is equal to x adjacent over hypotenuse, which is 25. So 25 cos 37 is equal to x, which means x must be equal to, you can probably already guess it's going to be the same one, but let's just type it in. 25 cos 37, what do you know? You get the same thing. You get 19.9, did I write that correctly? Yes, 97. Whoops, 97 kilometers, and that's at 2 decimal place values. So I hope that gave you a quick insight into trigonometry with true bearings, and hope to see you in the next one. Best of luck.